This is 4.6, day 2, number 39. So we're trying to look at how many sign changes happen with g of x. So currently we see a positive x to the 6th and positive x to the 5th, so there is no sign change there. But from x to the 5th to negative 3x to the 4th, there's a sign change. And then from negative 3x to the 4th to the next one, that is another sign change. Then it stays positive, positive, and then right here, and changes from positive to negative. So we have three sign changes. Therefore, there are three positive real zeros. Three possible positive real zeros. Okay, so the highest number we can have is 3. Now let's plug in g of negative x. So that'll be negative x raised to the 6th plus negative x raised to the 5th minus 3 times negative x to the 4th plus negative x cubed plus 5 times negative x squared plus 9 times negative x minus 18. So we're really just trying to take a look at the sign changes here. Now, the sign only changes in the front if we have an odd power, like here, because anything raised to the even power will always change to positive, right? So just thinking about the negative x to the 6th, that's a negative times a negative, like 6 times, right? And then so negative times a negative is positive, negative times a negative is positive. 1, 2, 3, 4, 5, 6. I have one extra. And then negative times a negative is positive, right? So there's 6 values that you multiply, and so at the end it will be positive. So this would be a positive x to the 6th. This changes to a negative x to the 5th. This stays the same, negative 3x to the 4th. This changes to a negative x cubed. This stays as a positive 5x squared. This changes to a negative 9x and a minus 18. So after we take a look at that, now we take a look at what are the sign changes that happen. So we have positive to negative. That is one sign change. Then it's negative, negative. Now here's another sign change. Negative to positive, and then positive to negative, and then no more sign changes. So we have 3 sign changes when we plug in a negative x. Therefore, we have 3 negative real zeros. Okay, 3 possible. So now we have to list all the possibilities. So positive real zero is 3. Negative real zeros would be 3, and the total number of zeros we have for this function is 6. So 3 plus 3 is 6, so we have no imaginary zeros. Now, if we remember our complex conjugates, which has to do with I, right, the imaginary number I, those have to come in pairs. Because looking at the original here, there are no I values. So in order for there to be no I's, you have to have a positive I as a solution and a negative I, positive and negative I as a solution. So what that means is you can only have imaginary zeros in pairs. So that means you can only decrease the positive real zeros and negative real zeros by 2. So if we decrease the positive real zeros by 2, that means this could be 1. Let's leave this at 3. If we decrease the positive real zeros by 2, that goes in the imaginary because we have to have 6 total zeros. So 1 plus 3 is 4, 4 plus 2 is 6. Another way to rewrite this is let's keep the positive real zeros as 3. Then we drop the negative real zeros down to 1, so that's 4. And then 2 more for the imaginary zeros, that's 6. Then the last possibility that we could have is making the positive real zeros 1 and the negative real zeros 1. Therefore, we would have 4 imaginary zeros, and that still totals a number of 6 zeros. Okay, so the biggest thing to note is that you can only drop the sign changes by an even number, by -2, decrease it by 2. You cannot decrease it by 1, right? The complex conjugates, they always come in pairs.